Okay, so in the last video we looked at using some simple mathematical operators, and hopefully I pointed out some logical or some computational logic along the way. This time we're going to extend that a little bit, and we're going to look at modulo specifically and how it works. And maybe we'll look at a little bit of what we can use it for as well. So I'm going to start by getting rid of this because it's starting to bother me that it's printing out on the screen on the left hand side there. So if I say print 5 divided by 5, hopefully we're good enough at maths to know how this is going to come out at. Run that, save it. It comes out with 1. Specifically it says 1.0. It's handling it as, this is an important point, it's handling this as a float rather than a whole number. Now, float is a term that is used in Python to describe, or is used in programming rather, to describe decimal numbers. Integer is a word that's used in maths and in programming to describe whole numbers, but in this case we're displaying it as a float because the division might not come out as a perfect whole number. Okay, so 5 divided by 5 gives us 1. Hopefully that's no great shocker there. Okay, if we were to do, I don't know, 10 divided by 3, and we run this, hopefully no shocks here either. We get this weird number 3.33333. Eventually we get 5. Okay, which hopefully isn't too big a surprise either. Why am I showing you this? Well, I want you to see the difference between this and modulo. Okay, so when I do the exact same stuff, so I'll put a percent sign in here, divide by 3. This is going to return a whole number. Okay, it is going to return a whole number. In this case, it's going to give us 1. Okay, the reason being is because the 10 divided by 3 does not give us a whole number. So instead, it divides it by, it does the division and it returns the remainder. Okay, and what's kind of handy here is that we can use this for lots of different programming applications. Okay, if I divided 10 by 2, that does divide perfectly. So when I run this, we get a 0. Okay, the handy thing about this is, conceivably or pretty easily, we could use this to work out whether a number is a whole number, whether a number is a decimal number or float number. We could use it to work out whether a number is odd or even, which is really kind of handy. Okay, to do that, or to explain how that works, and I probably will do, but in a later video, it's kind of useful for us to know about a really key programming concept, which is a variable. Okay, now a variable is a placeholder for a piece of information. Before I demonstrate it, I often describe it as like a box inside of the computer where we've stored some information, and that box has a label on it. Okay, so imagine you're moving house, you're putting all your crockery and your plates and your cutlery and what have you from the kitchen in a box. You're not going to label that bathroom, you're going to label that kitchen. Same thing. When we're creating variables, we want an appropriate label for the type of information that we're going to have. And essentially we're taking a piece of the computer's memory and sticking that label on it. The way we define a variable in Python is to give it a name, we write the equal symbol, and then whatever it is that we want to put inside of that box is what we write after the equal symbol. For example, my name equals Mr. Walker. Okay. Now there's a few things here that are interesting for us. First of all, the way that this is written. It's not the only way to write a variable, but it is a very common way, and it's a way that I prefer. It's called camel case, whereby if we have more than one word in our variable, we don't have a space, we use a capital letter each time we start another word, with the exception of the first word. There is no reason why you have to do it this way. This is a convention though, and it does make life easier as a programmer. It makes it easier to read it. If you put a space in there, as far as the computer is concerned, this is 2 variables. 2 separate variables, it will cause an error. Okay, if you want to pause the video, try it out, promise you gives you some sort of error. In this case, we've got my name equals Mr. Walker. And this, hopefully we remember from a latter video, is a string. We know it's a string because it's between speech marks and it's in green. Now, why are we bothering? Well, if we had a program which had loads and loads of lines in it, we don't want to have to write out Mr. Walker over and over and over again. We also might want to manipulate that at some point in the future, some point further down the page, down here somewhere. And we don't want to have to like rewrite it every time. So we use this instead. If I ever want this piece of information to come out of my program, I'm going to call it using this label. And the most simplistic way to call it would be to say print my name. When I run this now, we get 0 from this piece of maths at the top. We also get Mr. Walker. You'll notice you do not get my name equals Mr. Walker or my name. You get the contents of my name. This is quite an important concept, and what I suggest you do is just have a little bit of a fiddle around in idle, make sure you create 1 or 2 different variables, and you try and print some of them out. It's also worth trying to maybe add them together. I could do a quick demonstration. My first name, oops, must have hit caps lock. My first name equals Martin, and I'm just going to change this so that it makes sense. So I could say print my first name, and just for kicks and giggles, we'll put a plus in there to see what that does. So my first name plus my name equals, let's find out. Oh, I forgot my speech mark. Martin Walker, no space. Let's try with a comma. See what this does. Run Martin Walker with a space. So that was a little bit about Modulo, about how that works and how that returns the remainder of a division. It was a little bit about variables as well, and that's going to feed into the next video. Thank you very much for watching. Goodbye.